All right, welcome to Chapter 7 now. We're going to focus on exponents and solving some things using exponents. So today what we're going to do is do a little bit of expanding and condensing exponents to hopefully then in our next lesson take what we learned today and develop some rules. So let's jump right into it. So first of all, let's talk about what an exponent is. Again, an exponent, you've probably seen these before, such as this one here. We have 5 to the third power. Okay, you may have heard of them exponents as powers. They're really the same thing. Okay, so we got to think 5 to the third power. When you see an exponent like this, there's two terms you need to know. One, the first thing you need to know is what's called the base. Okay, the base is the number. In this case, it's going to be 5. The base is the number that's being taken to some power, and obviously then the exponent or the power, that represents what we're taking that base to. So here we have a base of 5, a power of 3. So I would say this is we're taking this 5 to the third power. Okay, then quickly reviewing, you guys should have a background knowledge on this already, but what does 5 to the third power mean? Okay, we use powers to represent multiplication, specifically when we're multiplying the same thing. So 5 to the third power would mean that this would be 5 times 5 times 5. So I'm multiplying 5 by itself 3 times. Most common mistake I see here is people saying, okay, this is 3 times 5. That is incorrect. What we're looking at here is a number times itself taken to that base, so 3 times in this case. So today what we're going to do is we're going to look at this idea of powers, talk about the base, talk about exponents, and we're going to talk about expanding and condensing powers. Okay, so let's take a look at two examples. So here I have first 2 to the third power. Let's talk about first, what does this mean? 2 to the third power, again, what this means is I'm taking 2 and multiplying it by itself 3 times. So my base here is 2, my power is 3. Okay, 2 to the third power would mean 2 times 2 times 2, which I can certainly evaluate to get an actual answer. But again, what we're talking about today is what is the meaning of power and what are we actually doing here? Okay, so we have a base of 2, power of 3, 2 to the third power. Same thing, I can do the same thing with any sort of number. I can do it with numbers, I can do it with variables, I can do it with fractions even. So I have 1/2 to the 5th power. So if we think of what is our base and our power? Well, our base is 1/2, our power is 5. So when I say 1/2 to the 5th power, that means I'm going to take my base of 1/2 and multiply it by itself the same number of times as the power. So here this would be 1/2 times 1/2 times 1/2 times 1/2 times 1/2. 1/2 to the 5th power. 1/2 times itself 5 times. Okay? So when we expand, we need to understand first what is our base and what is our exponent, and then be able to draw from there. Okay, so let's take this idea of base and power. Let's see if we can do the opposite. Now I'm going to give you a big string of numbers, and I want to see if we can condense this down. Condense is I'm going to take something longer and make it into something smaller. So let's take a look first at these 6 examples. So I have, in part A, I have 4 times 4 times 4 times 4 times 4. So notice it's 4 times itself. Now we have to think how many times. So from this I need to get a base. Well, look, first of all, I know that I'm multiplying 4 by itself. So I know my base is going to be 4. And how many times am I multiplying 4 by itself? 1, 2, 3, 4, 5, and 6. So this is going to be 4 to the 6th power. Okay, so what I'm doing is condensing this, taking something longer, breaking it down. Okay, the second one, B, -3 times -3 times -3. So notice here we're thinking about the number we're multiplying by itself. In this case, would be -3. -3 in this case represents my base. Now the power represents how many times I'm multiplying -3 by itself. In this case it's 3 times. So this would be -3 to the 3rd power. Okay. Next one we have a fraction. 2/5 times 2/5 times 2/5. What's the base? The base, 2/5. I'm just going to write parentheses around it. Okay, why? Because I'm taking 2/5 and I'm raising it to some power. I'm multiplying it by itself 5 times. So that means the base of 2/5 is being taken to the 5th power. Okay, all right, pause the video real quick. I want you guys to do D, E, and F. Okay, D, E, and F. All right, so I want you to pause and give those a shot. Here we go. All right, take a look at what you got. Here's what you should have gotten. D, we see we have x times x times x times x, 4 x's. So my base here, number in this case a variable, not a number, but we have it multiplied by itself 4 times. So here I can take a variable, x, and raise it to some power. So x times x times x times x would represent x to the 4th power. Base is x, times itself 4 times. Next one, we have a mix, numbers and variables. So I'm going to do these separately. I did 5 times 5 alone. What does that mean? Well, that's a base of 5 times itself 2 times, so that would be a power of 2. 5 to the 2nd power, and then I have times 5 y's here. So again, here's a new base of y, taken to the 5th power because there's 5 y's multiplied together. So combining those, I have 5 squared, or 5 to the 2nd power, times y to the 5th power. Okay, and of course I can evaluate 5 to the 2nd, but again, all I want you to get out of this is looking at the powers. Okay, part F. Okay, same idea. I have a number 3. I have a different variable of x and y, so I got 3 things going on here. Okay, 3 times 3 times 3, that's 3, base of 3, times itself 3 times, 3 to the 3rd power. X times x, base is x, times itself 2 times, that'd be x to the 2nd power, and y to the 4th power. Combining all those, since it is a big multiplication problem, 3 to the 3rd, times x squared times y to the 4th. All this is being multiplied, but what I'm doing is just condensing it down into something smaller. Okay, let's take a look now. Condensing, let's do the opposite. Let's expand. So let's see if we can do the same thing, but now expand it. So all I want you to write is we're going to write what this is going to represent being expanded out. We're not actually going to simplify. So 4 to the 3rd power, what does that mean in this case? 4 to the 3rd power. Okay, base is 4 times itself by the power, so that's 3 times. So that'd be 4 times 4 times 4. Okay, next one. 2/3 to the 5th power. I'm going to expand this one. 5th power, base is 2/3, so I'm going to start with 2/3. Power is going to represent how many times I'm multiplying 2/3 by itself. In this case, it's going to be 5 times. So I have 2/3 times 2/3 times 2/3. Oh boy, times 2/3 times 2/3. Okay, we're expanding this out. Next one, -3 to the 5th power. Expanding this here, we have -3 is our base. Now I'm going to put parentheses around this, just like I did with the fraction. To the 5th power would be -3 times -3 times -3. Running out of space, times -3 times -3. So again, I'm multiplying -3 by itself 5 times. Okay, this is all multiplication. I know I ran out of space here, but make sure you write that. That'd be one long line of -3s. Okay, I want you now to do numbers D, E, and F. Get it? Numbers D, E, and F. All right, here we're going to have variables and numbers. So let's pause video and give it a shot. Ready, set, go. Okay, boom, tough acted, tenactin. Here we go. D, M to the 5th. All right, 5 M's multiplied by itself. Expanded it out. 3 squared, or 3 to the 2nd power, x to the 5th power. This one I have a number and a variable, so I expanded the 3's. 3 times 3, that's the 2nd power. X to the 5th power, expanded that out. I got 3 times 3, and then 5x's all multiplied together. Part F, oh boy, I hope you stretched before you did this one. All right, number, x, and a y. So I got 2 variables and a number, expanded each out. 5 to the 4th power means 4 5's multiplied together. X to the 2nd power means 2 x's multiplied. Y to the 3rd means 3 y's multiplied together. Multiplied all those things in one long line, and that is what these powers represent. Okay? So again, we're expanding these powers. We'll see what happens. Now, why am I making you expand all these into big, long strings? Is because we're going to talk about next what happens when we expand, and are there some possible rules or some interesting things we can see from the results. All right, now we're going to do some problems where we are going to take the exponents and expand these. And then what we're going to do after we expand, we're going to try and simplify. So we are going to expand and then condense back down. Okay, you'll notice here that we're going to look at some things with similar bases. So let's start with the first one, A. I have 2 to the 2nd power times 2 to the 5th power. So what we're going to do first is we're going to expand both of these out. So 2 to the 2nd power, that means 2 times 2. Times 2 to the 5th power is 2 times 2 times 2 times 2 times 2. I count that out, that's 5. Now, what do we do when we condense this? Let's look. We have, how many 2's? We have 1, 2, 3, 4, 5, 6, 7. So, looking at this, I can condense this down back to 2 is my base, 7 is my power. So this becomes 2 to the 7th power. So what I've done here is expanded originally and then condensed back down, looking kind of at like terms. Okay, now I have 3/4 times 3/4 to the 2nd power. So again, let's expand this. That means 3/4 times 3/4 to the 2nd power is going to be 3/4 times, put parentheses there, 3/4. So if we look at this one, I have 3/4. I have 3/4 multiplied by itself 3 times. That's going to mean that our base is going to be 3/4, and our power is going to represent the number of times it's being multiplied together. So that's going to be to the 3rd power, and I'll just leave it as that. Okay, next one we got -4 to the 2nd power times -4 to the 3rd power. So again, let's expand this here. What that's going to mean, let's take this first one, -4 times -4. Oops, sorry, that should be a negative. Second one we have times -4 times -4 times -4. We have 3 of them. So again, if we look at what happens here, these are all -4s. Okay, all -4s. And how many do we have? 1, 2, 3, 4, 5. So if we were to condense this back down, our base would be -4. And what power are we taking that to? To the 5th power. So again, I'm expanding, then condensing. Okay, I want to see if you can do this. These next 3 examples, we have numbers and variables. Let's see if we can expand and then condense back down. Give it a shot, take a pause, ready, set, go. Okay, let's take a look-see. First one, D. I have y to the 3rd, y to the 4th. I expanded them both out. So y to the 3rd, I expanded out to 3y's, y to the 4th, 4y's, multiplied all together. If I look at it, okay, I got a bunch of y's multiplied together. So to condense it back down, my base in this case would be y. My power, counting up the number of y's, should be 7. So I have y to the 7th power. Okay? All right, then I look at the next one, 2x to the 3rd power times 4x to the 4th. So I just expanded the first one out. Okay? 2x to the 3rd is 2 times x times x times x. And the next one, 4x to the 4th, expands out to that. Okay, now numbers-wise, 2 and 4, I don't have a same base there, so I just multiplied them together as is. So 2 times 4 gave me 8. But then x's, I have a whole string of x's. I have 3 and 4, counting those up together. I have 7 total, so that means my base would be x, my power would be 7. Okay, so those combined at 8x to the 7th. And the last one, F, is a tricky one. Here we got 3's, we got d's as well. So what I did is I expanded this one out. 3 to the 4th is 4 3's. D squared is 2. 3 by itself, and then d to the 4th would be 4 d's multiplied together. Now, if I look, again, it's multiplied all together, but I have 1, 2, 3, 4, 5 3's. So I condensed that back down to 3 as my base, 5 as my power, 3 to the 5th. D's, I have 1, 2, 3, 4, 5, 6. I have 6 d's, so that means d to the 6th power. So that's a lot of d's, okay? But again, all I'm doing is expanding and simplifying, or expanding and condensing down. Okay, you might want to stop and take a break, rest your hand. We got a lot of expanding going on. We're going to continue this. We got a little bit left here, so here we go. All right, next set, what we're going to do, a little different. We're going to talk about powers. So what we're going to do is take a power and raise it to a power. So take a look. We have the first one, 2 to the 3rd power. This is taken to the 2nd power. Okay, so we want to expand this out first. So let's expand, and then we'll simplify. So 2 to the 3rd squared, what this means, we start on the outside. 2 to the 3rd squared, that means 2 to the 3rd is my base. That really means 2 to the 3rd times 2 to the 3rd. Taking this, I can expand this even more. Start with the first one. 2 to the 3rd is 2 times 2 times 2. This one is also going to be 2 times 2 times 2. So expanding that out, what do we get? Okay, I get 2 times 2 times 2. I have 6 of them there. So this would mean my base is 2, my power is 6. Okay, so notice when I take 2 to the 3rd to the 2nd power, that's the same thing as saying 2 to the 6th power. Okay, let's try B then. B, I have 5 to the 3rd to the 4th power. What does that mean? That means 5 to the 3rd times 5 to the 3rd times 5 to the 3rd times 5 to the 3rd. Oop, that's a 4, not a 3rd. Okay. Oopsie daisies. Let's switch that. Okay. Now, why did I get that? Because again, I have inside the parentheses my base. My base is 5 to the 3rd. My power is 4. So I did 5 to the 3rd times itself 4 times. Now, if I expand these out, Okay, this one's going to be long. We have 5 times 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 5. Oh boy. Times 5 times 5 times 5. Holy strawberries, man. So what I did is I broke each of these down into them. So how many 5s do I have? Well, if we count them up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Holy cow. So that means I have base of 5. I have 12 of them multiplied together. That means this would simplify to 5 to the 12th. Okay, last one we'll do here with this example, I'll give you guys a pause to try some problems on your own. We have x to the 4th to the 2nd power. So again, inside the parentheses is going to be my base. So in this case, my base is going to be x to the 4th. Okay, to the 2nd power means x to the 4th times x to the 4th. Inside's my base, that's my power, tells me how many times I'm multiplying them together. Then I can expand x to the 4th. What does x to the 4th mean? That means x times x times x times x, all multiplied again by itself. So I'm going to expand those x's, running out of room here. Okay, sorry, that one's an x right there. Got a little sloppy, ran out of space. But counting up the x's, 1, 2, 3, 4, 5, 6, 7, 8. That becomes x to the 8th power. Again, on my base, I have a common x, 8 times multiplied together. That means my power is going to be 8. Okay, what I want you to do is try D and E on your own. So give us a little pause here, and let's work on D and E. Ready, set, go. All right, here we go. Let's see what you got. So hopefully you grabbed your towel, wiped the sweat from your brow, and let's take a look. So I have 2x to the 3rd power. So what that means, inside the parentheses, my base, that's 2x to the 3rd power means multiply by itself 3 times. Then I expanded each of these out. So 2x, you can see 2 and then 3x's, 2 and 3x, all multiplied together. Okay, so looking at then the condense back down, I see that I have 3 2's. Now, no, they're not written next to each other, but everything is multiplied. So that means I have the base of 2 times itself 3 times. That's 2 to the 3rd power. X's, count them up. I have 3, 6, 9, all multiplied together. So I can simplify, condense it down, x to the 9th. Okay, so in the result, I get 2 to the 3rd, x to the 9th. Now, number E, get it, number E is probably the most grueling yet so far. We have 4 to the 3rd, y to the 2nd, all that to the 3rd power. So again, notice the parentheses. That means I'm taking whatever's inside and raising it to the 3rd power. That means this is my base. This entire thing is my base. 3rd power means I'm multiplying it by itself 3 times. So that's 4 to the 3rd time, or y squared times 4 to the 3rd y squared times 4 to the 3rd y squared. Expanded each of these out. 4 to the 3rd means 4 or 3 4's multiplied together. Y squared means 2. Same thing here and there. Then looking at the 4's, notice I have common 4's, common y's. So I have 3, 6, 9 4's all multiplied together. That's going to simplify out to 4 to the 9th. Base is 4, power is 9. The y's, I have 2, 4, 6. That condenses down. I have 6 y's multiplied together. So that's a base of y, power of 6. So what we did there is we looked at what happens when we take a power and raise it to a power. Maybe if you take a look, I want you to just take a look at these and see if you can come up with some sort of summary on what actually is going on here. All right, almost done. Almost time for a break, but we're going to grind through these last problems. Let's take and divide. Let's talk about what happens when we divide these things. So we're going to look at, again, what's called a quotient. Quotient means division. So what we're going to do is expand and then condense back down. So we'll talk about a few things here. So first of all, 2 to the 4th divided by 2 to the 2nd power. That means 2 times 2 times 2 times 2 over 2 times 2. So I expanded both the numerator and denominator. Now let's see what happens. Notice here we got to think. Okay, think mathematically. I have a 2 and on top and a 2 on the bottom. Same thing here. 2 on top, 2 on the bottom. What happens to those 2? Well, 2 over 2 is just 1, so they cancel out. Same thing there. They cancel out. What am I left with? I'm left with simply 2 times 2. Okay, so what happens there? 2 times 2, that's a base of 2, power of 2. Okay, because I'm raising it to the 2nd power, it's multiplied by itself twice. So notice how that simplifies out to 2 to the 2nd power. So do the same thing with x's. Expand the top and bottom. X to the 5th means x, 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 x. X to the 3rd means 3 of them. Now, you have a variable over a variable. Same idea. Anytime you have something divided by itself, they simplify, they cancel out, right? So I have an x on top that's going to cancel out with an x on the bottom. Notice that happens 3 times. How many x's am I left with? X times x. So what does that give me? That means my base is going to be x. My power is going to be 2. So a little different here with quotients. Okay, next one, 10 x to the 7th, 2x squared, or to the second power. Let's expand this one. So this is going to mean 10 x to the 7th is x over 2x. Okay, now let's simplify as much as we can. So I look at the x's. I have 2 on the bottom, I have 7 on top. 2 of them are going to cancel out. Okay? So that's going to leave me, if you think, how many x's left over to multiply together? That's x. Base is x, power is 5. Then I have 10 over 2. Well, hey, that's a number. What's 10 over 2? 10 divided by 2 is simply 5. So that simplifies out to 5x to the 5th. Okay, I'm going to give you some grueling ones right now. D and E, I want you to pause and see if you can work on these. Ready, set, go. All right, let's take a look at what you got. So, number D, get it, number D. Here we go. We have 3y to the 6th, so I expanded it out. 3 and then 6y's. 12y to the 4th, that's 12 and 4y's. Now I kind of canceled things out like a dingus, so I apologize. But notice 4 on the bottom, 6 on top. 4 of these cancel out. A y divided by a y would cancel out and give you a 1. So what am I left with? Well, 4 on top cancel, that's going to leave me with 2. So I apologize, there's 2 y's there that are left over. That's going to give me the y squared. Then I look 3 over 12. Okay, 3 divided by 12, that's not as nice as 10 over 2. I don't get just a simple whole number. But again, I can simplify this. 3 over 12, divide both by 3, you get 1 over 4. So this simplifies out to 1 over 4 y squared. Okay, so that's your answer there. Simplified, condensed back down. Now E, this one's a fun one. Holy cow. I expanded my 2's, 2 to the 5th, I wrote 5 2's, x to the 4th, 4 x's, 5 y's, boom. Okay, down here, 2 2's, 3 x's, 1 y. Now I canceled out 2 of the 2's, canceled out 3 of the x's, okay, canceled out 1 of the y's. What am I left with? Well, I'm left with on top, 3 2's on top. That's base of 2, power of 3, left with 1x. So that's base of x. And really, if I want to write this, that's a power of 1. And then lastly, I have y, 4 of them here, y to the 4th power, and I am done. Okay? You might need to, after this one, give your hand a good stretch. All right? When I'll see you in class, let's work on some more problems, and make sure you stretch your hand and bring a towel to wipe the sweat. All right, guys, good work today. We'll see you in class. Adios.